Hi, my name is Mateo Dristis. I'm a current senior in the honors program here in the College of Engineering. I'm doing my undergrad in data science with a minor in math, and I'm excited to show you my capstone. And so without any further ado, let's jump right in. So for my capstone, I did an analysis of political biases using deep writing with the help of my advisor, Professor Hampson, in the stats department. So a little overview. We'll go through kind of the background and goals of the project. We'll talk about the naive Bayes classifier that was used, the deep writing that was generated with recursive neural networks, and the surveying results from our project. So the motivation of this project comes from kind of the term fake news and a lot of what's surrounded that in recent years. You can see on Google Trends here, there's a term that was relatively, unused until it kind of exploded around the 2016 election time. And looking at kind of how the U of M library system defines it, it's basically any news that's reported without any backing up of facts, sources, or quotes. So our research question, kind of what we wanted to explore is, how can our biases affect our ability to detect fake news, and how can we try to measure that? So our goals first would be to can we classify news? There's a general understanding of maybe which news sources might have what bias, but is there anything we can look at the text of those sources and find a way to actually classify that bias? The second is, can we write any news from this? So if we take a large number of previous articles, can we write a new article? And lastly, detect. So, once we create these fake articles presented to a real person, can they be able to tell the difference? So for classifying, these are two common images if you look up news source bias. And, there's always going to be this kind of, it's hard to put an exact label on where a news source might fall. You have multiple writers for the source. Sources can kind of change their exact leanings over time. So what we did is we looked at a lot of different research articles and kind of came up with a general average. And so here on the far left, we have left wing and left skew, center kind of no bias, right skewed, and then right winged. And these were three major sources we picked from each of those that had the kind of largest number of articles in our data set. So for each article in our data set, from those 15 media publishers, we took that article and calculated the average sentence length, the average word length, and did one hot encoding for each word, which basically assigns a 1 if the word is present or a 0 if it's not. This left us with a massive data frame. We ran that through R's naive Bayes classifier and ended up with about 36% testing accuracy on those previous 5 classes. That accuracy rose about 10% when we combined the skewed and winged on the left-leaning and right-leaning side into just left and right news. Moving forward, this was actually the 3 classes we used for our deep writing for the main reason of, as kind of mentioned earlier, there's not as clear a line between left skew and left wing as there is between kind of left or right and no bias. So for writing articles, what we did is we took all our left of center articles, ran that through a recursive neural network and got kind of our output from that, and did the same with our right of center text. This ended up working using TensorFlow and recursive neural networks in Python, but there were a couple problems, and not so much in the actual writing, but more so in the readability. So some of those challenges were repetition of using the same word. This, especially when it was a verb, could stand out as kind of more computer generated than written by someone. Sentiment analysis was another problem where, the actual sentence might not reflect kind of what actually happened historically. And then continuity, which would be that maybe a third to the fourth sentence in an article, all of a sudden it would change subjects. And so it might be 2 sentences that sound like they're from the same time, but it doesn't have that kind of natural flow to it. So kind of how we went about fixing that for the survey to make it a little, tougher to tell what was from the neural networks and what is actual news, is we took an actual article, sampled a random sentence, and then from our output found a bunch of similar sentences, similar determined by number of kind of overlapping words. Then took those sentences and kind of merged them into one kind of new sentence. So as you can see from the top bubble to the bottom bubble, we're no longer talking about the same thing, but that bottom bubble is probably the closest to a real news article sentence of all the kind of other neural network output sentences we've looked at. So our next and final kind of goal was to be able to predict. We had a survey with 11 questions. 5 were kind of your baseline bias, where both were actual articles, and 6 were where one was a recursive neural network output and one was an actual article. For all 11, there were 3 options of selecting that one article was computer generated or neither were. And so here is kind of an example question. Feel free to pause this and kind of read through the 2 and see what you might choose. We'll come back to this in a second. I first want to share kind of what the survey results were. So of our group of 18 participants, they ended up being a pretty unbiased group, both in the baseline and the testing set. And so kind of looking at it, we couldn't see any shift in bias, and with the hypothesis test, we also couldn't reject that these were 2 different distributions. But there were still some really interesting takeaways. So one, going back to the question from before, this was actually the most incorrect question among the sampled group, as 13 out of 18 guessed the paragraph on the right was computer generated, when in fact it is actually the paragraph on the left. On the left, you can see kind of some of the things we were talking about before, of illegal appearing twice, immigrants appearing twice, so kind of that repetition of words there. He said is the most common verb, also reoccurring a lot. Well, on the right, I think what might have happened here is this is directly from an article, but they do say in the last line, you decided to say home instead of stay home. And so it is possible that this typo from an actual article could be causing that misclassification from those who were sampled. Another takeaway was one participant said after the survey, I felt I didn't have enough context sometimes to make a decision. And this was kind of like the aha moment for me with this project of, the goal was never to create the ultimate algorithm to write kind of the perfect fake news that no one could tell, but rather to kind of raise awareness and kind of make people, a little bit uncomfortable with the thought that, oh, a computer could write that. I maybe should double check what I'm reading or go to a different source to confirm it. And so kind of getting this reaction from those taking the survey kind of did help me feel that we kind of achieved what we set out to with the project. Some personal developments. I was able to further develop my skills in R and Python. I learned a lot about recursive neural networks and TensorFlow. That was really the main body of the second goal of the project. I had known really very little about them going in, and so that was very cool to kind of learn and explore. And lastly, I was able to explore kind of the intersection of statistics and political science, which was really cool. So thank you for listening to my presentation. I know that kind of usually this is a question time, but with this kind of recorded format, please feel free to post any questions below, and I will be checking in throughout all of April to answer them. Thank you very much.